Okay, we ready to get started? Hi, everybody. Thanks for coming to this session. I'm Tim Hunt, Senior Product Manager at Amazon S3. I'm glad you're all here. I'm looking forward to talking to you about some new features on S3. There's a new feature we launched today. We'll get into some detail, and I'm pretty excited about that. We've also got some existing functionality I'll talk to you about. These may be some parts you may be familiar with, but many of you probably aren't using these parts to their full potential. So I'll show you a little bit about that. Let me go ahead and dive in. So here are the topics we're going to cover. We're going to start with that new feature, S3 event notifications, and we'll spend a fair bit of time going into some detail there. Then we're going to move on to versioning and lifecycle policies. We'll show you how you can use those together in some newer ways. And then I'm going to round it out with some top tips for using Amazon S3. So S3 event notifications. Just launched this today, as I mentioned. It was announced during the keynote this morning. I'm particularly excited about this, and we think that it's going to be very interesting to a lot of customers. This new feature allows you to deliver notifications to Amazon SNS, Amazon SQS, and to this new service, Lambda, which I'll talk about a bit. So I'm going to break that down, give you some of the details. It starts with events. Now, events are things that happen in your S3 bucket, some action. In many cases for this launch, it's going to be events surrounding a new object being created. So in many cases, you'll think about this as a put. So a put into an S3 object. Now with this feature, you can generate an event notification. With that event notification, you can send it to 3 different locations, as I mentioned. First at the top here, there's SNS topics. SNS, Simple Notification Service. That's an AWS service. It's a push model. It allows you to send alerts to email addresses, to mobile alerts, also to HTTP endpoints. So that's SNS. The next option here is SQS, so SQS topic. SQS is Simple Queue Service. This is a really good option if you've got a workflow perhaps you want to trigger in response to an event in S3. You can set up your worker fleet to pull those messages off of the queue and work them. Again, really good for triggering workflows. The last one here is this new service, Lambda. This is really interesting for us at S3. It's a new compute service just announced today. It allows you to take your code and run it in the cloud with no administration. So what I mean by that is there's no instances to think about, no servers to maintain, there's no scaling to think about. You just simply write your code, and we run it for you on demand. And it's a really good model to match with event processing. So if you have an event that you need to trigger some compute, you might want to consider Lambda. It's in preview mode today. You can go and sign up. Hundreds have done that already. And we think it'll work very well for a lot of customers to take those events in S3 and process them in Lambda. So what are the benefits, or what's in it for you? The big story here is about integration. And we often use the metaphor of building blocks with AWS. So we'll talk about S3 as a building block, and EC2, and DynamoDB. And we talk about how you can put these together to build whatever system your application or your business requires. Well, we've now taken the S3 building block and we've put a new surface on it. It's a new interface. You can now connect S3 to compute and to workflows, to processes through these new event notifications. And it allows you to think about how you architect your system or how you design your system a little bit differently. You can now take targeted pieces of code that perform a function, processing perhaps on an object or taking an object to the next stage, and you can link these together. You can trigger those through event notifications. But it's not just for new applications. You can also use this as a really nice way to extend an existing application, even in a legacy application. If you've got an application that puts some data into S3, you can now do more with that data. Say, for example, you wanted to take a final report that gets placed in S3, and you wanted to parse that, put it in a database, or maybe put some analysis of that on a dashboard. Instead of digging into your existing application or your legacy application and adding complexity there, you can now build on top of that application using an event notification to trigger that processing. So we think it's pretty interesting. We're talking about this as event-based computing. And I'd encourage all of you to think about what that might mean for the way you design and extend your systems. The next benefit here is speed. So if you want to kick off some processing or send an alert soon after a change occurs in S3, you can use a notification to trigger that, and those typically arrive in less than a second, so pretty quick. And then the last benefit here is simplicity. There are customers today, we know, who need to react to events in S3, and they have a couple of ways of doing that. One of the ways they do that is they take S3 and they put a proxy layer in front of it so that all the requests pass through their proxy layer, and that's the way they can capture those events. We know other customers have taken to a process of periodically listing all the objects that are in their bucket. Compare that to a list previously, and any new object they recognize as newly created, and they can then do something about it. So these are some options that can work today, but now we've given you a better solution. You don't have to think about the scaling issues you might have to for a proxy. You don't have to think about the listing itself for a very large bucket. It can be pretty resource intensive and pretty slow. And it's also those other attempts or those other methods can introduce some delays. Now with event notifications, S3 takes care of that part of the puzzle for you. We handle the notification generation, so you can just focus on what's really unique or important to your application. You can focus solely on your code, which is what you want to have happen when that event occurs. We also recognize that while there are some customers who are doing this today, many customers probably saw that as too big a barrier, and so they haven't thought about reacting to events. But now that we've made it easy, we really are looking forward to seeing what many of you do. And speaking about what you might do, here's some of the examples that we've heard from customers. So we've talked to a number of customers who've been interested in this feature. They've helped us, given us some feedback along the way. And as we've talked to them about how they want to use notifications, they've highlighted, or as we've looked across their answers, we've identified a couple of main use cases or a couple of main applications. So I'll summarize those here. The first one, which is one that comes up frequently, is the idea of taking a media file and transcoding it in some way. So the classic example here is an image file arrives in S3, and you need to resize it or create a thumbnail. You can kick that off with an event notification. Another option is maybe a video file that a client might be uploading. There's another case where you might want to transcode and kick that off with a notification. Another class here is updating data stores. So you may have a cache that you use associated with S3, and you know, as we often see, that the objects that arrive most recently are typically the objects that are most frequently accessed, so you might want to warm the cache with those new objects. You might also have data that you're storing somewhere else, maybe in DynamoDB, maybe you're keeping some metadata there, or you want to. Event notifications gives you a way to kick off that process of updating your other data store when you have a change in S3. The third category here is really quite a broad one. It's similar to the first one, but more generalized. This is processing data files or log files when they arrive in S3. I'll give you an example of one customer who was really interested in event notifications and talked to as we've been developing them. This is an electronic data interchange company, EDI company. Every day they have millions of files flowing through their system, and these files represent transactions from vendors to retailers. They're things like invoices and orders that get processed. And when they took a look at event notifications, they recognized the opportunity here that they can change the way they interface with their customers. If they teach their vendors and their retailers how to put objects directly into S3, that can be their touch point for their customers. There are lots of tools already that can work directly with S3. Lots of companies know how to use the S3 APIs, so that's not a very big burden. And it allows S3 to be their touch point for their customer. And in fact, in their words, S3 could be their API. So that's pretty interesting for them. Now they don't have to create their own API and teach people how to do it. They don't have to work as hard as S3 has on things like availability and reliability and security and durability. They can use the S3 API directly. So they're really excited about that. Another option here in the same category, just another example, you might use CloudWatch logs. and you can have those delivered directly to S3. Now, if you want to do some processing when those logs arrive, you can do that. And then the last general category here are the object change alerts. So particularly if you have a person, perhaps, that needs to be notified that there's a work product they need attention for, or maybe another manual process, you can send that email or that mobile alert based on the event notification that happens in S3. So again, these are some of the ones, some of the use cases that our customers have told us about. And we're really, though, looking forward to see what you guys do. We keep hearing about interesting ideas, and we think this is going to be pretty interesting for a lot of you, too. All right, I'm going to switch over to a demo. We describe it here first, and I'll show you a little bit more of how I set it up through some screenshots. This is going to be that prototypical example. I'm going to take an image that gets put into S3. I'm going to have that generate a notification. I'm going to send it, in this case, directly to Lambda. We're going to use a little bit of Lambda code. That Lambda code is going to create that thumbnail back in a new bucket in S3. And I'll show you how really easy this is to set up. So I'm going to use some screenshots to show you what the console experience would be like. This is now the S3 management console, and this is the panel that you see for events for a bucket. You can set up your configuration here, starting by choosing a name. I've just entered my notifications. You can choose the events that you want to send notifications on. There's 5 that you see here. Again, for most customers, a lot of the activity is going to be around object created. I could select the parent category, that's the top created all, or I could select individuals. So I could select just puts, or I could do a combination. I could do puts and copies. So there's lots of options here. In this one, I just selected the parent category of all objects created. Then I have options of where I want to send my event to. So I've got those 3 options I've mentioned before. I've got topics, I've got queues, and I've got Lambda functions. If I stayed with the SNS topic, I could choose the topic here, or I could enter one, paste one in. I'm going to switch over to the Lambda function, and now I have 2 more inputs. So the first one is the Lambda function ARN itself. So the ARN, the Amazon resource name, is the ID of that function. You can enter that there directly. And then the next one is the invocation role. Now, the invocation role for Lambda functions with integration with S3, this is the way we control permissions for that Lambda function. This gives you control over granting S3 permission to call that Lambda function on your behalf. It's also the way that we make sure that whoever's hands-on here on the console, or whoever's using your SDK, actually has permission to give S3 that authority. So there's kind of 2 steps in that chain. And the invocation role is the way we manage both of those sets of permissions. Once I entered that, I hit save. You'd see in the console the list of notification configurations. There's just one listed here, the one I just created. But you can see there's another button there to add another notification. So I could create more than one on the same bucket. I could create, for example, a configuration that said, all objects created, send that to Lambda, as I've just done. And then I could add another one, perhaps, that said, if I lose an RRS object, I want to have that notification go to SNS or someplace else. Let me walk you through some of the code now for Lambda. Lambda today in preview supports JavaScript and Node.js. So this is some Node.js demo code. It starts with setting up some variables. So we've got the source bucket and the source key and the destination bucket and the destination key. In a few minutes, I'm going to show you an example notification message body, the actual contents of the notification message. You see that's in the, or you will see, that's in the JSON format. And of course, being in JavaScript, that's very easy to work through. This next part is an important part to discuss for a couple of minutes. I'm doing here what we call like a sanity check, and I'm making sure that the source bucket and the destination bucket are not the same. You might have ideas as to why I'm doing this. So you can, and in some cases you may want to, set up a situation where you create a loop. The idea being you could have in a bucket a notification when an object arrives. that can send the notification over to maybe some Lambda code that could put an object back in that same bucket. Of course, that's going to generate another notification. So you might, in fact, in some probably less common cases, you might want to do that. You might want to be progressively resizing smaller a series of images to a base size, or maybe you're working with map tiles you want to subdivide. In most cases, you probably don't want to do that. So we're recommending some best practices to avoid it. This one's a really simple one. I'm just simply using different buckets. After that, I do a quick check based on the key name to see if this is one of the types of files I want to process, a JPEG or a PNG, and I exit if it's not. And then on this next slide, I do the real work with the file. So first, I'm going to download it from S3. I'm using the node.js SDK here, so it's pretty simple to do these calls to AWS services. So here I simply download it. Then I'm doing the thumbnailing itself. We're using ImageMagick library, which is available in Lambda. So that makes that step rather easy too. And then finally, I'm uploading the object back to S3. All right, let me show you this in action. Do that. And there we go. OK, so this is now the live S3 console. I'm going to go out here, look at my bucket list, and I'm going to choose the Lambda demo bucket. I just showed you how you can set up notifications. If I looked over here under events, you can see I've got my notification already configured. And what I'm going to do is I'm going to go in and upload some files now. Oops. But I have to select them. OK, so I'm going to pick some of my favorite flower pictures. And I'm going to upload those to my bucket. There you see them. And see what an example looks like. This is my red flower picture. But now, if I go back to my buckets, and I go back to my resized bucket, there they are. It's like magic. Thank you. Now, I realize that I had meant to show you this bucket was empty before I started. You're going to have to take my word for that. But trust me, it happens just like that. It was empty when it started. OK. Let me go back to the slides. Great. I'm going to tell you a little bit more about the notification feature, and then we'll show you one more demo. So the first thing here is there's no additional charge from Amazon S3 for event notifications. You will pay for any associated use of SNS or SQS or Lambda, but again, no additional charge from S3. As you saw, when I configured this, you do it at the bucket level. So you can have a set of configurations, perhaps puts going one place in this bucket, puts going someplace else in another bucket. Again, it's at that bucket level. And you saw the event types that we're supporting at launch. The first four, put, post, copy, multi-part, complete, those are the ones that are associated with objects created. Those are probably the ones you'll use most often. RRS, object lost. If Amazon or AWS or S3 detects that we've lost one of your RRS objects, this is an event that'll get fired. Couple more points here. One's highly reliable. So this is designed for 9 nines of reliability with at least once delivery. That means that it'll be a very rare occurrence that you'll have an object, for example, put into S3 bucket and not receive that notification. Also very rarely, but you could have some cases where you have one put and you get multiple notifications. So you'll have to design for those. And then the last point here is that the destination needs to be in the same region as your S3 bucket. So if I've got an S3 bucket in, say, our Oregon region, and I want to send that to a Lambda function, I'll have to have that Lambda function in that same Oregon region. We do that for reliability and some performance reasons. I mentioned that the contents of the notification are in JSON format, so here's a quick sample of that. We have, by the way, talked to the other teams around around AWS. So we've adopted a standard here. We've got a standard overall framework, so if you're working with other services and other services are going to continue to adopt event-based features, you'll see some commonality here in the format. So if you look here, oops, don't do that. If you look here, we've got at the top some standard information about the event, what region it was in, what the event was. This is an object created put subtype. Some information about the request, the source IP address, some of the response header information. And then for S3, some of the more interesting information is in this S3 block. So we've got information about the bucket, what its name is, who its owner is, and the bucket ARN. We've got information about the object. So we've got the key, the size, and the E tag. I'm going to pause for a minute here on the E tag. A question that comes up for customers or from customers as we talked about this is, what about the consistency model, S3's eventual consistency model? Well, this feature works within that same existing eventual consistency model that we have at S3. And what that means is that you could have an object in S3. You could overwrite that object with a new put that generates a notification. And then when your code goes to get that object, it's possible with eventual consistency, you might get the previous version. E-tag is one tool that we give you that you can compare the E-tag that's in the notification message with the object that you might get out of S3 to see if it's the same one. Another thing to consider for eventual consistency is to use versioning if you want to make sure you're getting the same version or that you need stronger consistency. OK, let me go into my next demo. So the first one I showed you was using Lambda directly. Again, going to be a great choice for a lot of use cases. But I also wanted to show you a use case that uses SQS and Java, because these are also good use cases. So in this example, I'm going to take another object that gets put into a S3 bucket. As I said, I'm going to use SQS as the message bus here, so notifications going to SQS. Then we're going to have a bit of Java code you see there in the middle. That's going to be pulling those messages off of the queue. It's then going to be pulling the object out of S3. It'll be looking at the data in the object, putting some of that in DynamoDB, again thumbnailing and putting that back into the S3 bucket. And then finally, over on the right-hand side, we have a web page that we're going to use to display it. So let me show you some of the demo code here. This is the main loop of the demo code. It's really quite simple. It starts first with polling the SQS queue to get the messages. It then processes those messages. And you can see this is where the real work happens. So on the next slide, we'll go into more detail for that step. And then simply deletes the message after it's been processed. So then that process message method. This one starts by parsing that notification message, pulling out some of the variables we want to set up again, bucket name, object name, thumbnail name. We have a separate function here that parses the JSON, and then we can pull out that information. Then we do another check to see if potentially we're in another one of these looping situations. In this case, we've purposely chosen an example where we're using the same bucket. You may or may not want to do that, but if you do, this is an option to avoid that looping if you want to. In this case, we're using a naming convention. So when we create our thumbnails, we're going to give them a prefix. And then when we check each notification, we're going to see if that object already has that prefix. If it already has the prefix, we know it's a thumbnail we created. So we're just going to discard that message, or we're going to exit from that one. Once we're sure we have the right object type we want to deal with, we're going to download the object from S3. And then here in this second page where we do most of the work, first we're going to get the GPS location data out of the EXIF data that's part of that file. Then we're going to put some information about this photo into DynamoDB. So we're going to get the bucket name, we're going to get the object, the GPS location, and we're going to put in a URL there for some easy access later. After that, we're going to generate that thumbnail and put it back in that same S3 bucket. And then lastly, there's actually a second SQS queue I didn't mention up front. This one is used to trigger the web page that displays the results, so that page knows it's got a new object to display. All right, let me set up for this next demo. So I'm actually running the Java code here in Eclipse locally. You could, of course, run it in EC2 or many other places, as was shown. And let me switch over. There you go. OK, so I'm back here in my S3 console. And here I'm going to choose a different folder, which is my GeoPictures folder. So this starts empty again. I could show you quickly in the Properties panel. I've got this one set up to go to SQS. You can see the SQS queue that it's set up for. And I'm going to pick a number of files. And start the uploads. OK, here they come. I'm going to flip over here to my web page, and you can see as they're uploaded, they're kicking off notifications, going through that processing of creating the thumbnail, getting into DynamoDB, and displaying those images right here on the map. Pretty cool, huh? OK, so I want to show you one more thing with this demo. And here, it's not just because I want to have a selfie of myself on stage at reInvent. Everyone smiling? All right, so the point here is that I'm using standard Android phone, and I've got a basic S3 app. This is nothing special for my demo. It's just a basic S3 app downloaded from the App Store. And I can have this app upload to that same bucket. So as I find it, and in my tests of this, I will warn you, the connection here is really slow. So this may take some time to upload. Here it goes. Oh, it's going better. And there it is. Not the best selfie. OK, thanks. So again, it's a standard tool, nothing customized, but this is an example, kind of back to that EDI example, where you can take an existing tool, and you can, because it knows how to use S3, you can now integrate it into your workflow and into your application. OK. OK, so a couple of key takeaways. Again, event-based computing. We're pretty excited about this at AWS. We think you ought to think about how you can maybe change your applications, existing applications, or add functionality to existing ones or create new ones. Opens up some interesting possibilities. 3 destination choices, SNS, SQS, and Lambda. And again, no additional charge from Amazon S3 for this feature. OK, let's move on. I'm going to talk now about versioning and lifecycle policies. These are 2 features that have been for S3 for a while. But I'm going to give you some of the basics, and then I'm going to show you something that's newer about how you can use them together. So versioning first. The purpose of versioning is to protect you from accidental overwrites or deletes. And you can do this without any performance penalty. That means that you can have a bucket with versioning enabled, and you get the same performance as a bucket without versioning enabled. The way versioning works is that it creates a new version for every new object. So if you've got an object at S3 and you create a new object, or you upload a new object for the same key, instead of deleting that first one or replacing it, you get multiple versions. We keep all of them. In a similar fashion, when you have versioning enabled and you issue a delete, we don't actually delete the version. We maintain it, but we put a delete marker on top so that the system knows it's been deleted logically, but in the versioning space, there's still a version, so you can recover. So this gives you the ability to easily retrieve an object that you've deleted, or to roll back to a previous version if you've overwritten by mistake. It's helpful for you guys to know that there are 3 different modes now for a bucket in terms of versioning. There's the default mode with versioning turned off. This is the standard behavior you'd expect from S3. If you put an object into the same key, you overwrite the same space and the previous ones are lost. Similarly, if you delete an object, that object is deleted and it's lost. That's the default behavior. Again, with versioning turned on or enabled, you get that behavior where you get multiple versions and you get delete markers. Once you've got versioning turned on, you can also go to a versioning suspended state. When you go to a versioning suspended state, any version you've already created stays. It's still there. It's protected. But we don't create new versions. It's back to that default behavior where you'll overwrite the same key as if versioning were not turned on. So that's versioning. The next feature, lifecycle policies, this also has been around for a while. I'll give you a quick overview. So it allows you to do automatic tiering to a different storage class and also allows you to control cost. And it does that through two different actions. One is transitions. A transition is when we archive an object from S3 to Glacier. And you can do these lifecycle rules on a time basis. So you can say, for example, 30 days after each object is created in my bucket, I want it to transition to Glacier. By the way, if you're not that familiar with Glacier, it's a archiving specific storage class. It has a somewhat different access approach in that you request and then wait for the object to be available, but it's at a much lower cost. Getting back to lifecycle policies, expiration is the other option. Expiration is really a delete. So you can, for example, you can set up a lifecycle policy that says, I want to delete every object when it becomes 90 days old, for example, in this bucket. And you can do those two things together. You could say, maybe I've got my logs, and I want to keep them readily available for 90 days. After 90 days, I want to archive them. I still want to have them, but I don't need to access them that often, so I'll save some money. And then after a year, maybe they've exceeded their usefulness, and I just want to delete them. So you can set up that kind of staging. And then the last point here is that lifecycle control can happen at the prefix level. So you can have objects in your log prefix have one set of rules, and maybe objects in your data prefix have a different set of rules. But what's newer about these two features is how you can use them together now. And then we've added some functionality to lifecycle policies in particular back in May of this year that allows you to use those on the non-current versions. With these two things together, you can create what you might call a recycling bin that has automatic cleaning. So we get customers who call us every once in a while, somewhat panicked, saying, I've deleted my object, how can I get it back? Or I had a bug in my software and I've overwritten all my data, what can I do? And there's not a lot that they can do at that stage. But this gives you a way that you can give yourselves a kind of a safety net, a way that you can recover from a situation like that. So versioning, really versioning is what gives you the recycling bin. It maintains those versioning so you can recall those objects if you've deleted them or if you've overwritten them. And then lifecycle policies, as I said before, we've now extended those so they don't just work on the current version, but they can work on these versions that are behind the scenes, the ones that are in your recycling bin. And you can decide how long you want to keep them. So you can define how long your window is. You might say, I want to have this recoverability for 7 days or for 30 days or whatever suits your interest. OK. I'm going to show you quickly how you can set up this recycling bin type functionality. I'm going to use some screenshots again in the management console. So I've got a bucket here, my recycle bin bucket. And if I open up on the right here, my versioning panel, you can see versioning is turned off. There's a big blue button you can click to enable versioning. It's as simple as that. Now versioning is turned on. As I said, when versioning is turned on, you can suspend it. So there's another equally big blue button, so you can suspend versioning or go back and forth. But that's as simple as versioning is to turn on. If I then look down at my lifecycle panel towards the bottom, I can add my lifecycle rules. This bucket doesn't have any to begin with, but I can click by that green button to add a rule. And that gives me a 3-step process to define a new lifecycle policy. So first I decide, do I want the rule to apply to the whole bucket or just a prefix? Then I can choose what actions I want to take both on that current version and on the previous versions. In both of these cases, I have 4 choices. One is really to do nothing. The first is to archive only. After that, I could expire only, or I could have that staging archive then expire. In this case, we're going to leave do nothing for the current version. And when we get to the previous version, we're going to say we want to permanently delete it. And we're going to say we want to do that in 7 days. So then I just give it a name, review it, save it, and there you have it. I've got my lifecycle policy set up for this bucket. So now I've got both versioning and my lifecycle policy. And I'll show you a little bit about what versioning looks like in the console. By the way, everything I've done you could also do through the SDKs, so back through all my demos and the thing I'm doing now. All these things are, of course, accessible through your SDKs as well. But here's now that slide, here's now that bucket where I've got 2 objects. And this is now a version bucket. So if you look at the top, you see this hide show control. And if I click on show, I see a little bit more of what's happening behind the scenes for versions. Now you can see I actually have 3 objects in this bucket. It's just that the bottom one, just that the bottom one had previously been deleted, so there was a delete marker on top. The top one you can see, I've had 2 versions that I've one written on top of the other, and I can keep both versions or roll back to either one. So that's versioning and life cycles. Okay, so now let's round this out with some top tips for Amazon S3. The first one's a little bit of a gimme, I know. I just talked about this in detail, but we know that a lot of customers perhaps aren't aware of this, and we think it'll make a lot of sense for a lot of customers. So one more plug for versioning and lifecycle policies. Give yourself that recycling bin that you can also control and manage the cost. The next tip is to understand the 3 server-side encryption modes we now have on S3. And we've got a new one that was just announced yesterday. So first is the original server-side encryption model where Amazon S3 manages your key. That's simple, check the box, and you've got encryption at rest for your data. The second option was in response to some customers who wanted to manage their own keys. So they didn't want to take on the burden of creating a library or using a library to do the encryption client side, but they still wanted to be able to control their keys. So we've offered this now, server-side encryption with customer-provided keys. In this mode, you provide your encryption key as you put an object or as you get an object. S3 does the encrypting and the decrypting, but again, you control your keys. And then there's the new option. This was announced yesterday during the keynote, the new service, AWS Key Management Service, or KMS. S3 is now integrated as another option for server-side encryption with KMS. KMS gives you some added benefits. One of the biggest ones is permissions that you can control in those keys. So KMS, again, if you didn't see the keynote, it's a new service across AWS that allows you to centrally create and control your encryption keys across AWS services. So in KMS, you can control the permission of that encryption key, which means for your sensitive data, you now can have 2 layers of protection. You have both the access permissions for S3 itself, which we've always had, but you also have separate permissions on using the key. And if somebody wants to get the object out of S3, they need to have both permissions. So it's an extra layer of protection or extra layer of control there. You also get with KMS auditing of your key use. So if you want to see when your keys were used, and also if you want to see when your keys were attempted to be used but were rejected on permission basis, you can see that through the KMS service. The next tip is detailed billing reports. So we periodically hear from customers. I had one yesterday, actually, that said, how can I get data on my usage down at the bucket level for what's at S3? You could, of course, do this programmatically. For some very large buckets, that can be kind of resource intensive. But turns out you already have an option, which is detailed billing reports. These provide object count, storage in gigabytes, requests, data transfer usage, and they do this down at the bucket level. To get to them, you need to start at the billing and cost management console, and you'll find a section there on the left for preferences, and you can turn on these detailed billing reports. When you do that, you can ask to get those reports delivered directly to an S3 bucket. Now, if you're thinking about my earlier presentation, you could, of course, kick off a notification to process that, little plug for events. The other tip I'll give you here is that when I tell some customers this, they say, no, there isn't bucket detail in there, but there is. And what you need to look for is the reports you can download. So there's some you can download through the console. There's others you can have directly put into S3. If you want the most detailed reports, look for the ones that you can download from the billing console. Okay, the next tip here is restricting deletes. So if you have data that you're particularly sensitive about it getting deleted, you can start with a bucket policy that restricts deletes, just limits who or perhaps allows nobody to issue a delete request. And that's a start, but you might want to go farther. You might think that people who have the permissions set up in your bucket may be a little more liberal than you'd like. And you might have somebody who don't want to be able to get in and, in fact, change policies and make a delete. You might want to protect yourself against a malicious user even. So if you want to go farther, you could enable MFA deletes. So MFA, multi-factor authentication, requires additional authentication to either change the versioning policy or to delete an object version from S3. Once you have MFA delete enabled, it requires both the credentials that you would normally use for an S3 request and then a code from an authentication device like one of these fobs, as you can see there, in order for someone to actually make a delete. So really strong protection against deletes. And my last slide here is about maximizing performance. So we had, just before this, another whole presentation on maximizing performance in S3, and they went into more detail. PFC413, if you want to, if you didn't attend it, if you want to go see it. I'm going to give you some highlights here about these two parts, because really no list of tips for S3 probably would be complete if we didn't touch on these 2 points. The first one is about a key naming scheme and how you want to think about your key naming scheme if you're interested in higher TPS, or transactions per second. This gets important if you're thinking about TPS above 100. And really, S3 can scale many times above this. We have customers who routinely have TPS in the many thousands. The way S3 does this is by partitioning your key naming space in your bucket. So it separates the key name into different partitions so it can spread the load of those transactions. That happens over time, and S3 will do that automatically as it sees your request rate grow. And the way you want to enable that is by giving S3 a basis to make those partitions, and that's that little bit of randomness earlier on. It can be just a few characters, 2 or 4, depending on your scheme, but that gives S3 the ability to partition efficiently. What you want to avoid doing is using something like a date stamp up front. So you might have all of yesterday's objects with yesterday's day stamp and today's objects with today's day stamp. That essentially makes S3 start over partitioning each day because you're into a new partition space. So you don't want to do that again, add a hash, or if you want to have a timestamp, you can actually reverse it so that your seconds are first. That gives some variability. So that's key naming and TPS. And then the last one here is multi-part upload. Multi-part upload allows you to take an S3 object and upload it in parts. You can do these parts in parallel. You can do them in any order. And when you're done, you tell S3 you're complete. It'll reassemble your object so it's just one object up in S3. This gives you some benefits of being able to pause and resume. You can start before your whole object size is known. It also helps you if you've got a network connection which is perhaps not super reliable. Because if you're uploading a really big object and you have an interruption, you might have to start over. But if you've got a series of parts, you just need to restart those parts that encountered the errors. So it's helpful, particularly if you're thinking about maybe uploading from a mobile device. So it's encouraged for larger objects. And it's actually required for the largest objects. 5 gigabytes is the biggest single put you can do on S3. But if you divide those objects up into multi-part puts, you can get up to 5 terabytes, so much larger. The last point I'll say about multi-part is that the AWS SDKs do this for you automatically. So it's not hard. It's actually quite simple. And you might want to think about using it depending on your use case. OK, that was it. Thank you. I hope that was useful and helpful. I appreciate it. We will have a few minutes if you have any questions.